Good afternoon to everybody. So I will present the use case number 8, which is in the framework of landscape. So you will see that there are some strong connections with the presentation from Bertrand and Xavier. And the location of this landscape is the Doré Valley, which is located in the Vosges Mountains in France. I am the coordinator of this use case, but there are many contributors in ecology for the sensors, for stakeholder interactions, and then I will show you some results and some questions and what we want to do in PHENET project. So the territory of Dollar Valley is about 100 kilometers square in the crystalline Vosges. And the main feature is that it goes from 300 to 1,200 meters of altitude. So we have a large range of precipitation, temperature gradients, and also soils, because this valley covers only 1% of the Vosges area, but it covers 46% of the geological units. So that's why we focus on that valley, because it's important. We have a strong heterogeneity, and but even with this heterogeneity, we have some issues. We have a strong fir and spruce dieback, so you have losses of income impacted on the wood sector. We have an imbalance between forest and livestock, which pose problems for forest renewal, and so on. So we are typically in a forest which is in transition. Forests also is linked to drinkable water provision, because about half of the water supply for the population is made in the forest. So there are questions about the quantity and the quality of the water we provide to the populations, to the citizens. And also the Dollar Valley is well known for fishing, and the quality of the water and the quantity of the water in this river is very important for fishing. And the last one, it's recreation. The Dollar Valley is very touristic. So we have some landscape aspects. You can see the picture there, so taken from the top of the valley, and you can see that we have a lot of forest, but we have also villages. We have agricultural parts and so on, and really it's beautiful. So if you want to make a meeting in the Dollar Valley, you are very welcome, Bertrand. And of course, we have hiking, non-woody products such as mushroom, blueberries, and of course, skiing in the high altitude stations. And we have a lot of stakeholders. And just in one town in Masvo, at the bottom of the valley, we have about 60 associations, meaning that there is strong involvement of the citizens during the restitution of the different work we made there already. So what we made there, so we first started as usual by data collection. So you have several images there. How can I reuse that? Yes. So several images where, in fact, we are working with Agro-Paritech, which is a school, a forest school in Nancy. And we made two big campaigns with the students there, about 20 students that were crossing the forest and measuring trees, measuring soils, measuring the fir on the spruce dieback, and so on. So we made about 160 plots surveyed in the valley. And just to tell you, we measured there about 1,000 fir, and half of them were dying. So it's very important. It's like the storm in 1999. And to understand what is happening, we measured about 65 variables, that different traits and so on, to explain what happened. And in addition to that, we are working on at the scale of the Vosges Mountain. We are using about 2,000 plots, and we are using satellite aerial photos, and now we have LiDAR there. So what is going? In fact, the dieback is strongly related to the water balance, and this is new, the temporal evolution of the water balance. And in fact, the probability of mortality of dying of a tree is a function of the tree, depending of its dominant tree and the dominated tree. And if the tree so dominated, the stand, because the tree can be in forest framework ambience where cooling is important. The soil type, of course, climate, of course, and the climate evolution, which is quite new. And we found something that we could expecting, less mortality on lower north-facing slopes, deep soils with little waterlogging, and also little increase in soil water stress in summer. But what is important is that we show that we have less mortality in areas where trees are used to face water stresses. So in the Dollar Valley, in some places, we could have expect high mortality, but as they are used to face water stresses, they are not dying, and very close in other situations, trees that were not used to face water stresses are dying dying. So the questions for us there now is how we can zone the area to assess the vulnerability, the exposure to climate changes, and the challenges related to that. And we have to zone and to define the actions between zones. For example, we can do nothing. We let nature do as it wants. But we are almost sure that we will do not have fur in the future. Take action on the silviculture. We can change the way we are managing the stands and the way we are protecting the trees by keeping always trees on the field, avoid bare soils and so on. So we have changed some parts of the past forest management. It's already done, but it's on progress. And we can also act on the choice of the species if we need to plant. What are the provenances? Do we plant exogenous tree species, but very well adapted to the climate changes? And all is done in close collaboration with stakeholders. You will see that. And of course, the challenges is not only wood production, this is also biodiversity, water resources, landscape aspects, tourism, and of course, natural hazards, because we can have a lot of snow, for example. So we have to protect the populations using the forests. So our dream is, this is exactly what was explaining Xavier in his presentation. We need to connect ground data with IoT sticks that will measure the microclimate above ground and below ground microclimate, for example. We need to add products and tools from teledetections, from Sentinel, Pleiad, and other systems using LiDAR, airplanes, drones, and also what we call phenoman is it's like a phenomobile, in fact, but the moving is made by man in the mountains rather than a vehicle. And then where we can combine terrestrial LiDAR and photogrammetry and make some regular transect across the forest. And of course, using projections of the past and future climate and map all variables I was talking about before. So we need to make some data in assimilation to vegetation and soil models. So it's linked to PHENET Work Package 5 and machine learning systems in Work Package 2. And then the idea is to target forest growth and dieback in the future. And why we want to do that is that this is the part of CAPSIS. This will be implemented in CAPSIS. And but we have to link these biophysical projections forecasting to we have to move to agro socio-ecological systems for landscape integrated assessments, meaning that here we have to introduce stakeholders. We have to introduce the way they are interacting all together, the way they are taking decisions, and then we need to make a feedback between biophysicals and stakeholders. And so we have two projects for that. We have PHENET, of course, and we also applied to a national program, big program, which is called Fair Carbon, where we are implementing the connection between the platforms, simulation platforms. So the work in progress, we installed prototypes of a forest plug-and-play IoT sticks, and we are testing the sensor of these sticks against other sensors to be sure that we are not measuring. So we have to be sure that we do not have biased measurements. We have to set up, as said Xavier, the workflow of the data provided the IoT sticks, and then to use them in the modeling approach, and then to define the interaction with and involvement of stakeholders. So I will present the three kinds of these three parts. So the prototypes. So this is the forest plug-and-play IoT sticks. So you can see it. You can install them with a quad, and it's very simple to install. And it takes about half a day, including the soil sensors, which is the most important part of the time. And it's a plug and play. For example, if you want to install a new dendrometer, you just have to fix it on the tree. Then the cable is going in the green part there. It goes up to the sticks, and then you plug it, and the systems automatically recognize the device, and then you can collect the data immediately. So so you can see we have 20 possibility of introducing devices on each part of so it makes about 40 devices that we can plug on one stick. And this is in combination with the meteo stations, the weather station, combined also with the camera where we are measuring where we are taking one photo per day to have the phenology of the trees. Yes, that's the point. So how it works? So you have the sticks, which is called Sentinel Forest. Sentinel means that we are looking at the health of the forest. Then it goes to an application through the data transmission is made to one cloud with one system. The security is ensured by blockchains, and each stick is identified, and PIs can be differentiated between sticks if necessary. And then it goes to a storage center. And this is an example on the right part. You have an example of, so we installed this day, the thermometer that day, and you can see immediately how it goes, how the trees are growing. And then you can combine that with the rainfall. So you can see that we have no water stress up to this time. And then when you have a water stress, then increasing, then the growth is stopping. And then once you have again the rain and then reducing the water stress, then the trees are growing again. The consistency between sensors, this is important for us. So we install different sensors on the prototypes to check which one we would use in the different forests, including Dollar Valley. And you can see that for the temperature, ground temperature, we can use either of the sensors we installed in the stick because they are doing they are giving the same measurements of the soil temperature, given that they have been provided by different sensor producers. It's okay. And then we also checked the consistency with sensors already installed in the field, few meters abroad. And so we have a good consistency. What the differences you have here is that we use the raw data of the sticks. So the sensor has not been calibrated on the soil we install the sensor, and whereas this one has been explicitly calibrated for that soil. So that's why we have some discrepancy, and we were expecting such kind of things, but it's not a problem for us. And this is for the rainfall, for example. So here we are under story, and then here we have outside of the forest, and we also are about 16 kilometers abroad. So we have some differences, but it's quite normal because even with 16 kilometers abroad, you can have different fluxes from the west then you can have more rain even at 16 kilometers differences. And of course, we have less rainfall under the forest because the trees are evaporating the rainfall before it reaches the soil. So this is right in line with what Xavier presented because we will have to make a forest certification for an optimal monitoring design, meaning that where we will put the IoT sticks location, considering the knowledge we have, and also where we will do the phenomenon transect to have an optimal way of following the fate of the trees and the stands and the dying of the trees. So that's the first point. We would like also to have a follow-up of the forest dieback, backward and forward, using LiDAR and remote sensing data. So we had discussions on that with Xavier, and also which is something very important. We are measuring things on the ground, sometimes something with proxy detection and so on. But the idea is to have a full flow chart of the data for by using remote sensing products to feed the forestry generation, growth, and mortality models. Interaction with stakeholders and involvement. The first point you have to keep in mind that forest owners are not very typical for the Vosges forest, but they are typical from at national scale. So in the Doré Valley, most of the forests are private, which is not the case in the Vosges. It is completely the reverse, and you have also a lot of municipal forests, few state-owned forests, and very few county-owned forests. So the most of the Dollar Valley is privately owned, but some communes, some municipalities, such as Masvo and Sewen, own a large area of forest, and they are very active in collaborating with us because it's an important part of their income and also an important part for the tourism and so on for them. Forestry and wood industry players. Of course, the upstream sector is very well represented with numerous private forest owners and forest managers, but in contrast, downstream sectors are underdeveloped. And then the wood products are therefore mostly processed outside of the Dollar Valley. So this is an important point to have in mind because if you change something in the forest, then you have to be sure that the downstream sector will be able to process the new kinds of foods and so on. So for the upstream sector, you have a very classical actors such as public forest owners, private forest owners, forestry cooperatives, also institutions, organizations. There are also you have also associations of private foresters, forestry work companies, nurseries, and seed companies, but they are outside the valley of the perimeters for the last one. And the downstream, you have only one sawmill in the area, only one wood packaging manufacturer, 6 carpenter, because of course the habitats, the houses are still made of wood, except for example for the roofs. 3 interior furniture companies and 1 outdoor furniture company. And the one important part is that citizens are very aware of the forest because they are not only users, they are also they know that they are benefiting from the services given by the forest, and then they all say we need a forest. Maybe it will not be a fir forest, but we need a forest. And for example, the Vosges Hiking Association is very active on such kind of part. So this is what we are doing now. You see the interactions between the stakeholders and the environment. So when you have a crisis, then you have a plan from the state, which have some consequences on the owners, on the cooperatives, on the market, and so on. And so we are trying to show what is going when you have a crisis, how it works between actors, including hunters, citizens, and so on. So this is a diagram based on the economic and social sciences framework, and it's very useful for us to understand how it works and how the decisions are made at the scale of the Dollar Valley. Thank you for your attention. So this is a very nice view of the valley. I don't know if you see this well, but here it was a spruce stand completely crushed by bark beetles. And you can see that the fur is different. The dieback of the fur is different because you have patches of dying there, and so on. And the main point is how to deal with such kind of crisis. And for example, trying to avoid some bare soils after wood harvesting, because here you have erosions and you have a lot of programs on the water catchment there, and so this is such kind of issue we have to face. And of course, you have humans there, and the wellness of the humans is of major importance in this writing.